Hello, Algebra 2 students. This is Mrs. Sather, and today's lesson is about multiplication and division of rational expressions. So like we were mentioning yesterday, everything you learned to do with fractions when you were younger, well, we're doing them again, but this time with polynomials. So let's first practice a little bit of multiplication and division, just like you did way back when. If you have a fraction like 1/2 times 3/4, hopefully you kind of remember that you simply multiply straight across the top. So this problem really turns into 1 times 3 divided by 2 times 4. At this point, if you see anything that you can reduce, kind of like we did yesterday, that would be a good idea to go ahead and take care of that. But this problem doesn't have anything that reduces. We simply end up with the fraction 3/8. Okay. Then if you look at division, you may recall, is sort of the same as multiplication, but the issue with division is that second fraction, we need to make it a reciprocal because dividing is multiplying by a reciprocal. If we just kind of remember that fact, then what we end up doing is rewriting the problem. So this looks like 1/2 times 4/3. Okay, this is another one of those moments where if we see something that we can reduce, we probably should do it because it will make our life easier at the end. 1 doesn't reduce, it is reduced. 3 doesn't really reduce either, but if you look at the 2 and the 4, you can divide each of those terms by 2. 2 divided by 2 would be 1, 4 divided by 2 would be 2, and so now the problem turns into, as you look across the top, you're going to be doing 1 times 2, which is just 2. And then across the bottom of the problem, you'll be doing 1 times 3, which is just 3. So our final answer ends up being 2 divided by 3. That's the same idea we're going to use when we put some polynomials into our problem. So for example, number 1, these are very small polynomials. They're actually monomials, but that's okay. So knowing that multiplication is just multiplying straight across the top and straight across the bottom, I don't think I'm going to write these together as one fraction. I kind of already know that they are. But what I am going to start doing at this point is looking at the problem to see if there's anything that might reduce. So if I look at the 15 and the 3, those two numbers look like they're both divisible by 3. So 15 divided by 3 would be 5. And 3 divided by 3 would be 1. So now my problem has turned into 5 times 2x squared divided by 4x times 1. And I'm not going to write that extra 1 because we really don't need it. We know 1 times 4x is just 4x. All right, so our next step, see if there's anything else that reduces. So if you look at the 4x and the 2x squared, both of those can be divided by 2x. So if you do that, 4x divided by 2x is just going to end up being a 2. 2x squared divided by 2x ends up being an x. So now our final problem looks like 5x divided by 2. And that's what our answer is going to be for this simplified expression. It's just 5x divided by 2. Now, if you paid attention to what we did yesterday, you might remember we have these things called restrictions. We don't want the denominator of a fraction to be equal to 0, otherwise our function will be undefined. So if we look at our original fractions, there's only one of them that has an x in it, and that would be 4x. So if you set 4x equal to 0, divide by 4, it turns out that if x is 0, that's going to cause us a problem. So our restriction is that x cannot be 0 for this problem in order for our answer to be equal to 5x over 2. Example 2. So let's go to a division problem. This time we still have to do some factoring. So this factoring isn't too bad. This factoring is pretty decent. If you start off with the x squared minus 16, this is a difference of squares. And we had a special thing that we did with difference of squares. We took the square root of the first term, which the square root of x squared would be x. We also took the square root of the second term. The square root of 16 would be 4. And then we wrote the answer as x plus 4, x minus 4. We put a positive in the middle of one of those sets of square roots and a negative in the middle of the other set. The same kind of problem or same kind of situation is going to end up happening in our denominator of x squared minus 9, only this time our answers are going to be x plus 3 and x minus 3. All right, now we've made it to our fun fraction that gets to flip. All right, so we know that we need to multiply by the reciprocal. The reciprocal is going to bring that 3 up to the top. And then we're going to end up moving that 4 minus x to the bottom. Let's take a minute to remind you, 4 minus x can be changed around a little bit. If we start with 4 minus x, we could move this x to the front, which turns this into negative x plus 4. And then, since we really don't want our variables to have a negative coefficient, we could divide by a negative 1. So that could turn into negative x minus 4. So that is probably how we want to factor that. So sometimes you have to get a little bit creative with it, rearrange some things, factor out a negative 1. And then now that we've got to the fun part where we get to cancel things out, now we have something to cancel. We have an x minus 4 and an x minus 4. Everything else is going to end up staying there. Those x minus 4s are going to turn into 1s. So now let's see if we can write our simplified expression. So what I have left in the numerator is a 3 and then x plus 4. You could, I suppose, write x plus 4 times 3. It just looks a little strange to have a lonely little constant at the end. And then the denominator, well, you've got this over here. Don't forget about this negative that was down there in our second denominator. So we're going to have a negative 1. And then we also have our x plus 3 and our x minus 3. Now, some folks may insist that you go ahead and multiply all that back together. Typically, when I look at answers to problems, I want to see how you factored. So this is fine for me, but I will warn you, I'm not sure how the Pearson textbook Math Excel things work. You may have to multiply those things together. But anyway, if you made it this far, you'll probably be all right. All right, now we do need to talk about restrictions. If you look at your original denominators, the only terms that had x were right over there, again, with this x squared minus 9, and that's kind of a pain to try to deal with. So if I look at how we factored that, if we set x plus 3 equal to 0, and then x minus 3 equal to 0, turns out x can't be negative 3, x can't be positive 3. So our restrictions, we have our solution as long as x is not equal to negative 3 or positive 3. All right, problem number 3. We're back to one more multiplication example, and this one has a lot of factoring that goes with it. So I'm going to do a little bit of video magic with some of this factoring, just so that we don't have to sit here and talk through it all. We've been through this in class multiple times. You're free to pause the video and take a look at the things that I'm going to put up there for my work. So let's start off with our terms at the top. X squared plus 5x plus 4. We need to go ahead and factor that. And once we've done a little bit of work to see what numbers multiply to be 4 and add together to be 5, it turns out that we're going to have the factors x plus 1 and x plus 4. Then we'll move on to the denominator of that problem, 3x squared minus x minus 4. And once we've done our split the middle factoring by grouping, we end up having the terms x plus 1 and then 3x minus 4. And then we move on to the next set of terms. So if we take a look at the 3x squared plus 2x minus 8, it's going to be the same type of factoring. You have to multiply your first term and your last term. and then make a 4-term polynomial and factor by grouping. So once you've finished doing all of that work for the factorization, you end up on the top of the fraction on the right. You're going to have a 3x minus 4, and then an x plus 2. And then in the denominator for that fraction, what's going to end up happening is that we're going to go ahead and just factor out an x. It's just a greatest common factor situation. So you'll have x times x plus 4. And now we've made it to the fun part where we get to cancel things. So first things that I notice over on the left of the problem, you've got an x plus 1 and an x plus 1. So I can cancel both of those out. And when I do that, those both turn into positive 1s. And then if we go on across, you see an x plus 4 and another x plus 4 in the denominator. So those two things can cancel each other out. So those turn into positive 1s as well. We keep going. 3x minus 4 and 3x minus 4. Those cancel each other out. Okay. And then that's it. There's no more things to cancel in this case. So we'll just write our simplified expression. At the top we have 1 times 1 times 1 times x plus 2. So that's really just going to be an x plus 2. You don't necessarily have to write the parentheses on there. You can if you want. At the denominator, you've got 1 times x times 1. So you end up with an x. Now, the interesting part about this is that we do need to look for restrictions again. So we're going to look at everything in the denominator, all of the little pieces. So let's see if I can find a spot to write this. So we're trying to find our restrictions. If we look at our denominators of x plus 1 is equal to 0, we know that x can't be negative 1. The piece we have to deal with is what happens if 3x minus 4 is equal to 0. So if you subtract, or not subtract, but if you add 4 to both sides, 3x is going to be equal to 4. So we know that x can't be equal to 4 over 3. And then we have a couple more little pieces that we need to take a look at. So, of course, if you set x equal to 0, that's 0. And then if x plus 4 is equal to 0, then that's just going to be, that's just going to end up, so if x plus 4 is equal to 0, x is not going to be negative 4. So our restrictions, x can't be a lot of things this time around. X can't be negative 1. X can't be positive 4. Over 3. If I can get that to right. X can't be 0, and x can't be negative 4. Okay. Got one more problem for today, and then we'll call it a day. Please just draw here. Don't move anything. All right, so for example 4, we'll start by factoring our first numerator, x squared plus x minus 6, and that's going to be an x plus 3 over x plus 2, not plus, that's going to be. So when we factor x squared plus x minus 6, we end up with x plus 3 and then x minus 2. The denominator doesn't need anything this time. We do know that second fraction, because we are dividing, we need to make that fraction a reciprocal. So that little x plus 3 is going to come up to the top. And then when we factor x squared plus x minus 20, we end up getting x minus 4, and we get x plus 5. Okay, so now that we have everything factored, we can go through and do the fun part. We can see if there's anything that cancels. And for this particular problem, there isn't anything that cancels. It's all there, just the way it is. So we might as well write this simplified. So a couple of little tricks to writing a simplified expression. So in my numerator, if I look across the top row, I have a couple of x plus 3. So I'm going to go ahead and write x plus 3 squared instead of writing that out twice. Then I'm also going to write in x minus 2. And then in the denominator, I notice there's a couple of x minus 4s. So I'm just going to go write it as x minus 4 squared. And then write the x plus 5. I do need to go ahead and do some restrictions. When I look at restrictions, I have to look at the original denominators. So I have an x minus 4 and an x plus 3. So if I set those each equal to 0 and solve them, if x minus 4 is 0, then I know x can't be 4. And if x plus 3 is 0, then I know that x can't be negative 3. And we're finished. So if you have any questions, you can leave me a comment on our Canvas page, or you can email me. You can also go to Khan Academy, take a look at some of the great videos that they have there. They give you a few more examples, and they do work through every step of the factoring, unlike where I skipped over some things. Your practice for today is your Math Excel assignment, so make sure that you get on the internet and do a little practice, and we will see you next time.